Hello guys, in this video I'm going to show you how to solve zigzag level order traversal. So given a binary tree, populate an array to represent its zigzag level order traversal. You should populate the values of all nodes of the first level from left to right, then right to left. For the next level, you keep alternating in the same manner for the following levels. So given this binary tree, so the output we expect here is an array of 3 subarray, right? Each subarray corresponding to one level of the tree, and that is very similar with our first problem, binary tree level order traversal. The difference here is that we need to reverse the order alternately. So for example, for the level 1 is 1, right? But for level 2, we must the order must be right to left, which is 3, 2. Then the next level from left to right, 4, 5, 6, 7, and so on, right? So the idea is pretty much the same as our previous problem, right? But we just need to figure out a way to reverse alternately. Let's say for this problem, level order traversal, always think of using a heap. Using a queue, right? We're doing breadth first search, so use a queue. Our queue here, the element come in this way, and come out this way, right? So initially, there's one node inside. Keep a result array. Say the node out. So at each iteration, we want to process one level for one iterations, right? So for first iterations, we need to process one, right? So the node out, and at the I forgot to say that at the beginning of each iterations, the number of elements inside the queue is exactly same as exactly equal to the current level of the tree. So for example, the beginning is 1 here, it means the size of the queue is 1, and it is exactly the total elements of the level 1, right? So at each iterations, we process exactly that amount of element. So level size is 1 now, right? So we process one element only. We pop 1 now, so node out is 1, right? The level size is 1, so it means the first level should has one element. So the node now is 1. We just fill up the subarray with 1 die. Okay, as we popping 1 out, when NQ all the all of its children, right? So it's 2, 3 is children of 1. So we put 2 first in this way, and 3 comes second. Okay. So now we start to process the next level, right? The current level, the second level, has size of 2, which is the current size of the queue now, right? So we only want to process only 2 elements, right? The first one is 2. We pop 2 out. Okay. The level size is 2. It means the next subarray has 2. Let's say node out is 2. But here we want to alternate, right? Like we must have a way to reverse the order of elements inside here, like for each level. So probably one way to do that is use a variable reverse. So initially it's at node 1, at level 1 is true or is false, but here it should be true. So if reverse is true, we're gonna add from add 2 to the here instead, right? And okay, the next one is 3. Oh, I forgot. We need to NQ all of children, all of not 2 children, which is 0.5. 4 first, then 5. The next now is 3. Okay, push 3 here, and NQ all of children of 3 is 6 and 7. 6 first, then 7. Okay, we're done with level 2. We're done when we pop out total of 2 nodes, which is 2 and 3 is out there. So now for the next level, which is level 3, the level size is the queue size, right? It's 4. Okay, gonna reverse. Now is false. Okay, the level size is also the next subarray size. 2, 2, 2, 2, 4. Okay, node out is 3. Sorry, node out first is 4. Pop out 4. Node out is 4. Want to add 4 the first as a first element in the subarray 4 here. Okay, next one is 5. 5 out. Okay. Forgot 4 and 5 has no children, so we don't need to enqueue anything. Next one now is 6. Okay. 6 has no children. That's 6 here. 7 had no children. Yes, 7 here. Okay. Queue is empty now, so we're done. And here's a result. So let's try to code it out. We need a queue here, of course. So what we need here is to initialize a queue. Is new queue. The queue initially has one node, which is a root node. Okay. So as long as the queue is not empty, which is the length is greater than 0, I'm going to process the next level, right? So want to process next level. Okay, so level size is same as the queue length currently. Okay, we want to need to resolve array, right? Resolve. So before processing, we want to add a empty subarray to resolve. Push empty array. Okay, empty subarray. Okay, to reverse the order, we need a reverse variable. Initially false, right? So process wanna process exactly level size elements, right? So as long as level size is still greater than 0, we want to populate the next level, right? And process next level. So process. Then for each item that is pop out, to decrease level size by 1, so that we process exactly this amount of element. So note down is q dot pop, no, dot ship is dq, the note down dq. So here we want to let get the last subarray in the result. Last subarray is result come on, result dot length -1, the last index. After the last index of result, we get the last subarray, and depending on the reverse one, and depending on the reverse one, we want to add to this subarray in different way. So if reverse is true, we're gonna push to the end of the subarray. Last subarray push what? Push the node out value, node out. Now Okay. Else, I want to add to the head of the last subarray instead. Last subarray unship. Node out of val. Okay. Level size minus. Okay. We want to enqueue children of node out. Right. So if node out slab the slab of node out, we want to queue dot add enqueue node out dot lab. Okay. Same here. If it right enqueue node right. Okay. So after process one level, wanna toggle the reverse equal to whatever reverse now. Toggle it reverse. Okay. So after everything is done, exit it. When the queue is empty, return result. I think that's pretty much it. Let's run the test. Run just 7. Okay. 3. Come on. Oh, wait a minute. Result here. Not separate. What's wrong here? If reverse issue. It should be in another way. If not reverse, then push. Okay. Okay, it works. So thanks for watching. See you in the next one.